Welcome back to part 2 of my valve tester project. In this video we'll look at the construction and final testing of the device. I'm going to use strip board to lay out the components of the voltage doubler circuit, having checked that the ratings of the strip board are okay and fit for purpose. I'm going to use this design software to work out the layout of the components. Here I can hide components or show different aspects of the design and just focus on some key areas. I can even flip it so I can view it from the underside if I'm going to be cutting tracks from the underneath. It's really good to have a laser cutter for the construction of the prototype. It really helps to construct some temporary housings for the components. It was an easy job to build a voltage doubler on the strip board. Now it's time to test the voltages. Okay, so I'm in a position now to do the initial turn on. I built the voltage doubler circuit and I kind of arranged everything so the baseboard is going to be, or the bottom layer is going to be constructed permanently as it would go into the case. And this was easy really, there's really nothing to build in the voltage doubler, and I've checked this several times, so we're good to go. Really the bulk of the work is on the top layer where all the controls are, and there's a lot of point-to-point wiring there, so I've got this arrangement here and I'll just build it up bit by bit and test it bit by bit. I made this adapter really for testing the initial valve rather than using the banana plugs, and I can use this idea really for when we've got some unusual valve base types that we need to test, and I can just build an adapter for that and just plug it in with flying leads into the unit. So I've checked through all the mains. A lot of this exposed metal has been earthed for safety reasons, and so I think we're good to go really. So yeah, I'm just going to turn on the mains and then I'll turn on the unit and we'll see what happens. Okay, so welcome back. When I turned this on initially, I had a 250 milliamp fuse in this inlet, and that popped quite quickly. So after double checking the circuit, I'm reassured myself that everything was correct. I've just upped the size of fuse in there slightly, and we're in a good position. You can see I've already turned this on, and this is interesting because you can see how slowly it discharges once it's charged up. This little load resistor here is just taking the charge out of the capacitors. But we're in a position now just to check the voltages, so I'll just turn it on. You can see it's ramping up already. This is the low voltage setting, so it looks like it's settled in around 142 volts, which is a little bit higher than I would like. So we'll have to think about that. Let's just move it to the high setting. And immediately that's going up to about 286 volts. So I don't know if that's too high or too low. We'll have to have a little think about that. The critical thing here is that the circuit is working. Nothing's gone bang. It seems to be stable, no noises, no vibrations, fuses are intact. So I'm fairly pleased with that. So I'll probably just leave this on for a while just to give it a little bit of a soak test, and we'll just review the voltage readings that I'm getting. So I'm really pleased that the voltage doubler circuit is working. That's the heart of the system really. What I wasn't too sure about was the voltages I'm getting. It was peaking at 296 volts. So from a system perspective, what I can select is 296 volts, 222 volts, 148 volts and 74 volts. And looking at my collection of valves, most of those have a maximum anode voltage of 200 volts, sometimes 250 volts. So that higher range seems a little bit redundant to me. And it'd be nice to get something a little bit lower and something more selectable in the range of valves that I have. So what I've got actually is a very similar transformer to the one I have already. That's a 60 VA transformer in the system already. This is a 50 VA transformer, but it's a 24 volt one, so it's going to drop that voltage slightly. but I can still operate in that 2 amp range, which I want to be targeting. So really it's just a like for like swap. It's cable colours the same, so I just need to unbolt that one and put this one in and just measure the voltages coming out of this one. So that's the replacement transformer in. So on the low voltage setting I'm getting 123 volts. So if I flick this to the high, it's coming out at 248 volts. Now, I personally think that's perfect, given that 250 volts is the highest specification I've got. So I think I'll definitely go with this transformer. So I'm really happy with that. Although it looks like a massive spaghetti, it wasn't particularly hard to sort out all the wiring for the complete prototype. I did sketch out all the wiring on my design package, so I was able to turn specific wires on or off, so it made the routing quite easy. Okay, so I've progressed with the prototype. In fact, I've already done some testing, so I know it basically works as it should. And just to take you around what I've done, obviously these are the power supplies for the 2 meters there. Look quite large, but to be honest, there's no money at all for the 2 amp version, so I thought I might as well get those. Voltage W have already gone through, and this is a connector block really, which allows the upper layer controls to be easily disconnected from the bottom layer. And I'll obviously, as I go through the final build, I'll tidy that up. The rest of the components are mounted on a strip board, which will be mounted vertically to the top panel as well in this area here. So it kind of will look really tidy when it's all done. I've got the controls here. I just need to make sure those are centered off actually when we do a test, because I'm going to run through a test of this PCF805 valve, which is a pentode and a triode in a single envelope, and I've got the pentode section wired up at the moment. So what I found is actually with the valves is that so far you need to get valves which in terms of anode voltage match very closely to what can be generated by the unit. I'm not saying that's true of every valve, but it's certainly true of the ones I've tested so far. So a valve running at 120 volts anode voltage, and it's got specification of 160 volts. I found them not to work, so it may be just that particular style of valve. Also heaters as well. I've got quite a lot of valves with 9 volt heaters, which I didn't realise. But that's going to be taken care of because I've got an external heater jack as well for further down the line. So I'll get that unit when I can and just plug those in. So just a few safety things as well. What I've been doing with the debugging, I've been using these clips as much as possible. Definitely the earth is always clipped, so there's always one hand free when I'm probing around, really, because I don't want any situation where I can have these high voltages running across my chest or through my body. Likewise, I've got some indoor shoes on which have quite thick rubber soles as well. So I'm just trying to take some basic precautions there to protect myself. So definitely worth bearing that in mind. Another observation as well is that I've got this connected to the output of the voltage double at the moment. It's down to 25 volts. It takes quite a while to discharge. So you need to be just aware of that. You know, if you need to change the voltage, especially going from a high voltage to a low voltage, it takes time to bring things down. So I've got this wired up. I'm going to do a basic test. So make sure these are centered off for the screen and the plate. Very important. And we'll just turn the unit on. So what I found as well, the grid volts need to be turned really low. If you turn those really high, it tends to trip the short light, and that tends to come on. I've monitored the voltage each side of that, and it just brings it down to a point that actually just sparks the gas. So I've got it just turned down low at the moment, just to see if there's any shorts between the anode in the ground and the plate in the ground, and nothing's coming on with that light, so it just seems to be working right. So just letting the valve just warm up a little bit. It takes obviously going to take some time to warm up. While I feel it's okay, and I'll give it a go now. Just need to turn the unit off, and we just need to set the screen and the plate volts. I put those in high position. It's because it's a 240 volt anode device here. I've got the screen and the plate set to that high level to bring those in at around sort of that level. So you can always measure things off there if you need to with this meter, but I've got it clipped in at the moment. So what we need to do to measure the GM is to bring that grid volts to around -2 volts or -1 volt, and we should start to see some current being drawn as we get close to those values. We're coming into range. It's just starting to conduct now. So I'll bring it up to, try and get, it's a little bit sensitive. There's 1 volt there. So we need to just record that current, which is, it's probably still warming up actually. So I'm just going to give it a few more seconds. So it's got to make sure that's stable. It seems to stabilise there. I think that's fully warmed up now. So I'm kind of, I wouldn't say I'm rushing for the test, but I'm working faster than what I need to. So -1 volts, grid volts, that's 8.7. And if we bring this down to -2 volts now, there we go. So we're at 3.7, let's call that 3.7. -2 volts. Let's just do a calculation. So we've just got to look at the difference between those two values. Well, it's going to be 5. That's 5 milliamps per volt. And actually for this valve, the manufacturer's specification for the grid voltages in that range is actually 4.8 milliamps per volt. So that's actually very good. What we need to do is a gas test as well. So we're looking to see when we hit that button, whether that 3.6 drops appreciably. And it's dropped to it's increased to 3.7. So it's not radically changed. So I don't think that's a gassy valve by any stretch of the imagination. And actually that's the test done. So I think got a good valve there, and I think the tester is working as it should. So I'm very pleased with that. So obviously what I'm going to do now is just test a few more valves, get some confidence in the workings and very familiar, and then I'll work on the final packaging. There's actually a lot more work to do in terms of taking this prototype apart and then reassembling it in its final form. So let's look forward to that step in the process. I've got a couple of circuit boards which are located on the upper faceplate of the tube tester. I'm going to design some brackets so they can be mounted vertically where possible. So I'm using Tinkercad here to create some 3D print designs, and I'll go off to the printer and just manufacture those. My next task was just to tidy up the bottom layer before designing the faceplate layout. So I'm back on the drawing software to arrange the controls for the faceplate and also check the clearances between the components on the upper level and the lower level. I can also design a drill template. I can even flip that drawing to view the drilling from the underneath if I'm drilling from that side. So it's onto the machine of the panel, which is 1.2mm aluminium. I was dreading making a mistake in this process. It's not so much the cost of the panel, it's the time it needs to actually manufacture the panel. But I did get a chance to check the alignment between the top and bottom layers, and also a chance to see the panel inside the case, just get a feel for how the final project would look. So I've finally got to this point where I've actually completed the front panel, and I'm very pleased with the results. It's been a bit of a journey to get to this point. I've been very busy at work, and I've not been in the best of health, so I've had to put all my energy into my work really, so less time to pick up this and keep it moving forward. But I'm at this point now. Yeah, I'm not the world's best machine operator. Considering I'm using hand tools, I'm quite pleased with how this has turned out. There's just one or two holes which are slightly out of line, but the eyes aren't really drawn to them. So overall, it's very good. I was going to use the polished aluminium face on this, and it looks fantastic in the case with bare aluminium. But I did a lot of the measurements from the back and the machining from the back, and that created a lot of burrs. I was very careful to clean down the work surface, but inevitably I got some scratches through the protective screen, although they were quite light and there was only very few of them. And every time it gets scratched anyway, to me, I didn't want to carry on with those. So I sprayed up the panel. I was thinking about spraying it anyway, but I'm very pleased with the colour actually. It's a slight off-white, gives it kind of an antique feel. The stickers really are just stuck on, just a label print and just applied to the surface, and then everything's been sealed in. So at this point now, I'm actually ready for the final assembly, because the case has been earthed, that's all been made safe. The handle I managed to actually earth to the rest of the case just by using some spring metal really to connect to the rivets at the back of the handle into the frame of the case. So overall, I'm very pleased with that. So onwards now to the final assembly. So the next stage is to mount the components on the front panel and tidy up the wiring. Then we can complete the electronic sandwich. I've got to say I'm very pleased with the overall result. And here we have the finished tester. So all we need to do now is give this a final test. So I've got this small valve in here. It's a W77, which is a RF Pento valve. So just to make sure we got this tested correctly, I've pre-wired this and make sure the screen voltage and anode voltage are off. I tend to just bring this down initially and then bring it back up. So we need to ensure this is in a high setting. I'm going to apply 164 volts to the anode and the screen for testing this particular valve. So I'll be pulling those switches down at the appropriate time. So let's just turn this on. And you can see the grid voltage is at its bottom. There's actually no shorts there at all, so that's a good thing. As instructions say, let's just turn that off, and we'll bring the anode in and the screen, turn the device back on, and we'll just give that a few seconds to warm up. It's on the internal heater setting, which is a 6-volt heater. So let's just bring this up, and I did the research on the data sheet, so we'll probably take a reading at -3.5 volts, and we'll take a reading at -2.5 volts to get the GM. So it's just starting to conduct now, which is a good sign. Let's just bring this up slowly, and I want to be around 3.5. So it's 2.2 milliamps, and we'll just bring this to 2.5. That's about there, and that's 3.2. So it's about 1 milliamp per volt, which I think the data sheet said it should be around 2, so I'm not unduly worried because it seems to be conducting properly. Just hit the gas button. There's actually no change at all there to the to the current. So my opinion, that's a good valve. It'd be nice to compare very similar types just to check that GM value, but I'm basically happy that the tester's working and this particular valve's working as well. So here I am at the end of the journey, and I'm very pleased with the final results. I've got no regrets about taking this journey. I think for the expenditure and the quality of the tester I got at the end of it, I think it's well worth taking this route, and all the reasons I set out at the start of the video apply here. But let's just look at a few aspects of this build. I think first of all, the cost. It's supposed to be an inexpensive tester, and I think if you go to a well-stocked electronics store with a shopping list and walk out with one of everything, then it certainly is. I think if it did that, the total cost of this would be about £180, components less. Then you've got the case, you've got the panel, then spraying the panel. So there's actually a lot of extra work it needs to go in to get a finished product. So that said, yeah, it's the modern world is different, isn't it? We don't really have those stores, so we've got to mail order a lot of things. So you've got to factor in postage costs, and then often you can only buy in bulk 10 of everything or 5 of everything. So I've actually got a lot of spare components, and I'll be using all those components to build a valve rectifier and diode tester, and that's something I've worked out in my head how to make that work along this process. I'll be using the same voltage doubler methodology to generate the voltages, and I've got the spare transformer. So that's what I'll be doing. And we need to look at other aspects as well. I think one thing to bear in mind, if you're going to go on this sort of journey, then safety is paramount. Looking at the website behind the concept of this tester, reading some of the comments, I'm not so sure some people should be attempting work with this level of mains and voltage doubling. There's people there. One person wanted to connect a high tension transformer to the voltage doubler circuit. There's other people wanting to connect DC power supplies to the voltage doubler circuit. So it tells me that you don't really know what they're doing fully. I'm not saying you need to be an expert, but you need to be fully aware of what you're taking on and really understand what the function is of each module, and just respect the voltages. That's the main thing. Just be respectful of what it can do to you. So that said, I'm very, very, very happy, and I will be doing some more videos following this. There's some accessories I want to build, including the external heating supply, because I've got a lot of valves that need 20 volt heaters, that sort of thing. So I'll be doing that, and I've got a few radios I need to renovate, so I'll put those on as well. And I want to repurpose some of the television valves, maybe make some radio receivers or some amplifiers with those, and see if we can get those to work. It's just a little bit of fun. So yeah, if you've enjoyed it, then please like and subscribe. I will be doing some more content. But thank you for watching this video, and I hope it's been worthwhile.